Hi everyone, myself Karthikeyanes. Now I am presenting a project report on bank loan case study. Coming to the project description, assuming as a data analyst at our finance company, we are dealing with a problem like some city customers with limited credit histories are defaulting on loan. My job is to dig into the data and find patterns using exploratory data analysis. This helps us to make us we are not turning away good applicants while still spotting those who might not pay back their loans. Usually, the company faces two risks when processing loan application. The first one is risk of rejecting the capable applications. This risk occurs when the company denies a loan to an applicant who is fully capable of repaying it. It leads to a missed opportunity for the company to generate revenue from the interest payments and other fees associated with the loan. For example, imagine a customer who has a stable income and a good credit history, but is denied a loan due to lack of sufficient credit data. If this customer could have repaid the loan without issue, the company loses out on potential profit by rejecting their application. The second risk is of approving incapable applicants. On the flip side, there is a risk of approving a loan for an applicant who is unable to repay it. This leads to financial losses for the company in terms of principal amount of the loan, as well as any type of interest and fees. For instance, consider a customer who has a history of late payments or defaults on the previous loan. If this customer has approved for a new loan despite their risky financial behavior, there is a high likelihood that they may default again, resulting in financial loss for the company. We will be dealing it with the data set that includes loan application data. There are two kinds of scenario in it. First one is the customer with payment difficulties. These are the individuals who have faced challenges in making timely payments on their loans. Especially, they have experienced late payments exceeding a certain threshold on at least one installment within the initial phase. This group represents customers who have posed a higher risk of defaulting on future loans due to their past payment behavior. The second one is all the other cases. This category includes the instances where customers have consistently made their loan repayment on time without any significant delay or default. These customers are generally considered low risk in terms of loan repayment, as they have demonstrated a history of financial responsibility. In this project, we are focusing on four potential outcomes when a customer applies for the loan. The first one is approval. The company gives the green light and approves the loan application. The second one is cancellation. The customer decides to cancel the application during the approval process. The third one is refusal. The company decides to reject the loan application. And the fourth one is unused offer. The loan is approved, but the customer opts not to utilize it. The objective is to leverage exploratory data analysis techniques to gain insights into how various customer attributes and loan characteristics impact the probability of default. By examining these factors, we aim to understand the dynamics and identify patterns that can help us anticipate and remove the risk of loan defaulters. Next, the business objective is to pinpoint threats indicative of clients who may struggle with their loan installment repayments. This insight will inform strategic decisions such as whether to delay loan applications or decrease loan amounts or offer higher interest rates to applicants may risky. The organization aims to enhance its loan approval procedures and make more informed lending decisions by comprehending the primary factors contributing to the loan defaults. Moving on to our approach, we start by making use of the abundance of data on bank loan that is kept in our database tables. We do a comprehensive analysis of the dataset before running a number of queries to retrieve prominent facts. The first phase helps us to fine-tune our query strategy to get the most relevant data for our research and guarantees that we have a clear knowledge of all the information that is accessible. Moving on to the technology stack utilized by his analysis, I employed the following tools. First one is Excel. Excel served as the primary tool for managing all challenges encoded throughout the study. For data handling to comprehensive analysis, Excel provided a versatile platform to accomplish various tasks effectively. The second one is Canva. To compile a observation-based report, I turned to Canva. This user-friendly platform enabled the creation of visually appealing reports, effectively communicating the findings of the analysis to the stakeholders. Moving on to the insights, our first task is to identify the missing data and deal with it appropriately. As a data analyst, we discover missing data in the loan application dataset. Care must be taken while handling missing data in order to ensure the accuracy of the analysis. Using Excel's built-in tools and functions to identify the missing pieces of the dataset and to fix them accordingly. When it comes to the data imputation, finding any missing data using techniques like average or median together will Excel functions like count, is blank, and if function. I suggest utilizing a bar chart or column chart to visually illustrate the distribution of missing data across variable. Now we can see the all procedures in the Excel sheet. So this is the previous application dataset. This one is the current application dataset. This is the original dataset we are going to perform. For task 1, to count the number of blanks or missing values, we have used this formula count blank from the range H2. H2 means the column and the row number to the column name to the maximum range, that is 50,000 rows we are having. In order to calculate the proportion of missing value, we have used the count blank column name from the range, that is J2 to J50,000, divided by count, that is A2 to A50,000. So we can use any column like whatever the actual data range is, divided by into 100 to know the exact percentage. So after doing this, we get to know the number of missing values every column having, and also according to that we are getting the proportion of missing values. So we can see that I have marked several columns with different colors. By seeing this we can see that if the proportion of missing value is less than 50%, then columns having the numerical values, that is for the columns that are containing numerical values, we have performed the average and median imputations. The columns which are having the categorical value, for example name type suit, name income type suit, or categorical columns, we have to do the mode imputations. So if the proportion of missing value is above 50%, then we need to remove that complete column, so which will be affecting our data analytics report. So this one is the unique case, that is flag mobile. This column contains only one value, that is 0, which is not useful for any analysis, so we have removed that column also. In this Excel sheet, we can see that many columns have been marked with different colors. Here the blue colored column having the numerical data with less than 50% of missing values, whereas this light pink column having categorical value with less than 50% of missing proportions. Here this red color columns are having more than 50% of missing proportions. Only this flag mobile is removed because all the data are of unique value. Here you can see I have marked the several columns. These are all the columns having more than 50% of missing values. In the next sheet, here we can see all the columns that has been marked in the last sheet has been removed. And here you can see the distribution of missing values visualization chart. Here I use the bar chart to depict the values. Next, coming to the report. Next, upon analyzing the data, we have uncovered there are several missing values in the 122 columns and 50,000 rows in the original dataset. The code-black function was used to determine the number of missing values in each column, leading to an initial understanding of the data's integrity. It was realized that the absolute count of missing data would not be suitable for the analysis. Hence, the percentage of missing values in each column was calculated. This percentage analysis played a major role in the development of workable strategies for handling the missing data. Missing value proportion. In case where a column's missing values are less than 50% imputation was carried out by utilizing the column's numerical values, average or median values. Categorical values are inferred with the columns containing them using the mode. It was decided that a column was not necessary to be included in the dataset if it had more than 50% of missing values. Specific example, the flag mobile column in the dataset was removed entirely as all of its values are 0, rendering it unusual for analysis. Following data treatment guidelines, the dataset was reduced to 80 columns while retaining the original 50,000 rows. The dataset became more reliable for analysis and easier to work with as a result. These are the formulas I have used while doing this analysis. I have utilized this first formula for average when working with the columns that include numerical values. I have utilized this second method, the mode formula, for the columns that has the categorical value. So this is the chart. This is the bar chart to depict the proportion of missing values. Next, moving to the next task is to identify outliers in the dataset. It is crucial to identify the outliers in the load application dataset because they have the potential to seriously skew the analysis and produce false findings. Utilizing Excel statistical capabilities, identify and characterize dataset outliers with a focus on numerical values. Using Excel techniques like quartile, IQR and conditional formatting to find any outliers in the dataset. Using criteria or business rules to establish if these outliers are legitimate data items or whether further research is necessary. Making a box plot or scatter plot to visually represent the dataset numerical variable distribution and draw the attention to any layers. Next, coming to the Excel sheet. After removing all the columns that have more than 50% of missing values, now we need to highlight the number of outliers having in the data set. To know that, we have followed a certain procedure. That is, first we have done to know the quartile 1. So to know the quartile 1, we have this formula quartile, the range criteria, comma 1, that indicates quartile 1. Similarly for quartile 2, this is the formula. For quartile 3, this one is the formula. To know the IQR, we need to minus Q3 minus Q1 to get IQR. To know about the lower bound, that is Q1 minus 1.5 into Q3 minus Q1. So this is the formula to know the lower bound of the outlier. To know the upper bound, the same formula, in place of minus we need to plus, that is Q3 plus 1.5 into Q3 minus Q1. To know the outliers below the lower bound, we need to use this COUNTIF function, the range, and we need to mention this criteria like less than the lower bound. In order to know the outliers above the upper bound, we need to mention this upper bound range. To know the total number of outliers, we need to add both this lower bound as well as the upper bound to get the number of outliers. Next, to know the maximum outlier, that is the maximum value, which outlier is outstanding above the upper bound. So we have calculated this max value. After doing this, we have selected all the rows and we have pasted in the transpose. So by doing this, we came to know several columns having a valid data points, and some columns have no outlier. Even there are no outliers found. Here the children count, that means the client having number of children has not valid, because here it has the maximum value of 11. That means the client is having 11 children is impossible in these days. Next, when it comes to the income total, it is also invalid, because the client, one of the client is having 11 crore 70 lakh as a salary, so that one also invalid. When it comes to the days employed, that is before he is registered for the loan, how many years he have the work experience in the previous company. So here they have mentioned 36,000, 3,65,243. That means exactly 1000 years he has been working for the company. So this is also not valid. In this sheet, we have shown the various visualization chart to know about the outliers of each column. So we can see here the outliers that has been marked for each column. I have been marked here. Here we can see the outliers for the number of children the client has. So the dots above the certain horizontal line are the outliers present for each column. So here the amount income has one outlier, that is around 11 crore 70 lakh thousand, that is the one. Here for amount credit, here there are a few outliers, that is the amount credit is above 40 lakh, so that is also one. So here these are the other outliers found for each column. coming to the report. By doing this analysis, I discovered several valid data points in the range of columns. In addition, I saw that a couple columns have no outliers, indicating that the data was distributed rather evenly. However, on rare occasion, I discovered outliers that by predefined norms were deemed invalid. In a single instance, the outliers corresponded to individuals who had 11 children. By today's standards, this seemed unbelievable. One other unusual observation was a salary of 11 crore 70 lakh, which is excessive given normal condition. Furthermore, I discovered an anomaly that indicated 3,65,243 days worked, implying a 1,000-year employment history, a highly unlikely duration. Recognizing these outliers as invalid is crucial to ensuring the accuracy and reliability of the analytic results. In certain circumstances, further investigation or analysis is necessary to maintain the dataset's integrity. Appropriate actions such as data removal or cleaning may also be necessary. These are the formulas I have used for this analysis. For quartile function, this formula is used to determine the quartile 1 function. This formula is for quartile 2, second quartile, and this formula is for third quartile, and Q3 minus Q2, that is quartile 3 minus third quartile minus second quartile, is for IQR to know the interquartile range. This formula is for lower bound, and this is for the upper bound, and these are the other two functions to know the number of outliers below the lower bound and the number of outliers above the upper bound, and this is for to find the maximum outlier. And this is the analysis report, and these are the charts which have been performed for each column, that is amount credit, amount annuity, amount goods price, region population rating, etc. You can see here also. These are the lot of anomalies in the amount goods price, amount application, amount credit, and amount annuity variables. There have been blank deviations from the norm of 3 or 4 family members, especially when it comes to homes with 20 people. These omissions may indicate multi-generational or shared living arrangements. It is simpler to design personalized loan packages that take larger households' unique financial situations into account when these abnormalities are identified. Moving to the next task, analyze data imbalance. Data distributional imbalances may have an impact on the correctness of a study, particularly in cases where binary classification is involved. Thus, a comprehensive of the data distribution is necessary for the construction of reliable models. Check to see if the dataset of loan applications have any imbalances, or then calculate the imbalance ratio using Excel functions. To get the relative proportion of each category, use Excel's countif and sum function and compare the frequency of each class to determine the extent of the data imbalance. Let us go to the Excel sheet. Here, to know the data imbalance, we have the column target, and for to know the client who has no payment difficulties, so we need to use this formula. Countif, the range A2 to A50,000. Class 0 means target 0. Target 0 means the client who has no payment difficulties. So we have 45,973 clients who have no payment difficulties. When it comes to the client who is having payment difficulties, that is loan defaulters, we have used this formula. Countif, the range, that is A2 to A50,000, comma 1 means the target value 1. Count the number of ones in the column A, so that we have 4026 client who have the payment difficulties. To know the ratio of data imbalance, we have used this formula, that is B2 by C2, that is no payment difficulties column divided by the column having payment difficulties. By doing this, we have got the ratio of data imbalance of about 11.41. so this is visually represented in the pie chart. This yellow part shows the client having payment difficulties or the data imbalance. The around 92% shows that is class 0, the client having no payment difficulties. So coming to the report, by doing this analysis, it was discovered that there is a data imbalance, particularly when binary classification is involved. Excel functions like countif and sum were used to calculate class proportions, enabling a quantitative assessment of the data distribution. These types of insights are vital in guiding the development of robust and consistent models, ensuring their effectiveness in real-world applications. The ratio of data imbalance is computed 11.41902633. These are the formulas I have used. So this is the pie chart. Moving to the next task, perform univariate, segmented univariate and bivariate analysis. To have a better knowledge about the factors that contribute to loan default, it is important to conduct a variety of research on loan and client characteristics. Conduct a segmented univariate analysis to compare variable distributions for different scenarios, univariate analysis to understand the distribution of individual variables, and bivariate analysis to look into interaction between variables and the target variable by utilizing the features and capabilities of Excel. Using Excel's statistic functions such as count, average, and median for descriptive analysis, Excel's sorting, pivot tables, and filters may be used to conduct the bivariate and segmented analysis. Plot data as bar charts, histogram, or blocks plots are used for variable distributions. Creating a stacked or grouped bar charts to compare the variable distribution across many contexts. To examine the relationship between the target variable and the other variable using scatter plot will be more accurable. Next, coming to the Excel. So this is the dataset we have got after removing the missing values and removing the outliers. So here I have performed many formulas for creating a pivot table. For example, here you can see I have used the amount income column and target column. I have got the maximum income, that is by using the max formula here 11 crore 70 lakh, and minimum that is 25,650. By using this, I can able to do the income bins, that is income bracketing. So every 25,000 I have increased. After that, to know the number of clients having the income value 25,000 to 15,000 without payment difficulties, that is here you can see. Here you can see the formula for client who is not having any payment difficulties, that is target 0, with income bracketing of 25,000 to 50,000. So we have used the range here for the income, and we have set the criteria, that is greater than 25,000 and with the amount income lesser than 50,000. Check if the target value having 0, so that we get to know about 741. And for similarly for target 1, we have just changed this attribute. So similarly like that, I have used the credit bracketing. So here we can see for the credit bracketing, that is around 0 to 1 lakh, how many applicants are here. So I have used this criteria like greater than 0, less than 1 lakh and all to count the number of applicants. So in the same manner, for income bracketing, average amount credited. To know the client one who is having the income of 25,000 to 50,000, how much amount has been credited as a loan. So that in order to perform this one, we have used the average if else function with setting the limit of greater than 25,000 and less than 50,000. Here initially we have the days birth in minus symbol. So after using this formula, we came to the positive integer. After that, in order to convert these days into the age in terms of years, I use this formula. Like every year there will be a 365 days, and 4 year once there will be leap year. That's why I used 0.25. So here I have done the age bracketing, and similarly, like after doing the age bracketing 20 to 25 years, the client one who is having payment difficulties, like loan defaulters, that is target one, is calculated by using this formula. That is greater 20 age, less than 25 years, that is having target 1 divided by countif function, just calculating the total number of applicants. Here total number of applicants with target 1 divided by total number of applicants with the age limit of 20 to 25 years into 100 to get this percentage. So similarly I have done these many. Let us create one pivot table. Let me show you how to create that. So let us create this for a name contract type for cash loans and revolving loans. How many number of applicants are there, and first we will check about the loan defaulters. In order to create this, click on here, go to insert, click on pivot table, and then you need to select the range, table range. So I have selected only DR1 to DS3. Then I need this table in the existing worksheet. I will choose this as the destination and click on OK. Here we will get the this pivot table. So now we used to assign which column has a row and which one should be as a row and which one should be as a value. So let us click on this and drag this near the rows, and automatically the rows will appear like this. Then click on the loan defaulters and drag it near the values. Here comes the pivot table. After creating this pivot table, just click on any rows and go to insert. So click on here pivot chart. So you will get the pivot chart here. So you can use this, how many applicants are there having a cash loan itself, and how many applicants having only revolving loans with the loan defaulters, that is difficulty to pay the amount. Here we can see the various univariate analysis carried on different attributes. Here we can see the based on gender, how many loan applicants are here. So male having the lesser applicants compared to the female. Here when it comes to the type suit, that means the client having, that is while applying for loan, how did the client came, along with the children or with the family, or he came alone and all. Here the client one who came alone has the highest number of applicants. So here we can also filter. So compared to children and accompanied, that means the client one who came alone has the most number of applicants. Here in the same manner, when it comes to the segmented, here the client who came alone or with the children or with the family, one who has loan defaulter, that means one who has difficulties to pay the repayment, that has other B has the highest number of loan defaulters, that is 10.8. You can see here. So in this manner we have performed the several varied segmented analysis. When it comes to the bivariate analysis, here we can see the income bracketing with the average amount credited. That means the client having 25,000 to 50,000 income bracketing, how much average amount will he be credited here. So the client one who is having 4 lakh to 4,50,000 to 4,75,000 salary has the maximum average amount will be credited based on the loan. Here in the same manner, based on the income bracketing, average amount goods price, so that here we can see 5 lakh and above income bracket have the highest average amount of goods price. So like this we have performed the several bivariate, variate, univariate and segmented univariate analysis. Next, coming to the, by doing this analysis, it's easy to find potential predictors of loan default. Required a full understanding of each variable's characteristics, which could only be achieved through univariate analysis. Utilizing segmented univariate analytic approaches, variable distributions of many situations were compared. In order to look at correlation between the study's target variable and other variable, bivariate analysis was used. These are the formulas I have used to do this analysis. Here we can see age group of 56 and above has the largest number of applicants, followed by age group of 36 to 40. Here the average, the income range of 125k to 150k has the highest applicants, followed by 100k to 125k. Here the contract type cash loan has the highest applicants, that is 45,276. When it comes to the years employed category, 0 to 5 years employed has the highest number of applicants, followed by the 6 to 10 years employed clients. Females has the majority of loan applicants, that is 32,823. Whereas when it comes to the type suit, unaccompanied clients has the most number of applicants, followed by the family type suit applicants. The income type, when it comes to the income type group, the working has the highest number of applicants, followed by the commercial associate. When it comes to the education type category, the secondary or secondary special education has the highest number of applicants, followed by the higher education category. When it comes to the family status category, married clients has the highest number of applicants, followed by the single or not married applicants. When it comes to the uh, dwelling category, that is housing type. House or apartment having clients has the highest number of applicants, followed by the parents house in which the client has been living has the second highest number of applicants. When it comes to the occupation type, laborers has the highest number of applicants, followed by the sales staff. When it comes to the number of children, the client having no child has highest number of applicants, followed by the client having only one kid. When it comes to the organization type, business entity type 3 has the highest number of applicants, followed by the SNA group. When it comes to the number of family members, the client is having 2 family members has the highest number of applicants, followed by the 1 family member. When it comes to the category of not having a car, has the highest number of applicants. The client one who is having his own home or flat has the highest number of applicants. When it comes to the region rating client category, the rating of 2 applicants has the highest number of applicants, followed by the rating of 3 clients. When it comes to the contract type, consumer loans has the highest number of applicants, followed by the cash loans. When it comes to the credit category, 0 to 1 lakh credit category has the highest number of applicants, followed by 1 to 2 lakh credit range. When it comes to segmented univariate analysis, the borrowers that is 20 to 25 age group has the largest number of loan defaulters, that is followed by the 26 to 30 age group. When it comes to the contract type, the cash loan applicants has the highest number of loan defaulters. When it comes to the employment bracket of 0 to 5 years, has the highest number of loan defaulters, followed by the employment group of 6 to 10 years. Then the males have the highest rate of loan defaulters. Then when it comes to the type suit, the other B type suit has the highest loan defaulters, followed by the children category. That means the client has applied the loan by his own. When it comes to the other B, the category of the income type, when it comes to the income type, unemployed has the largest number of loan defaulters, followed by the working group. When it comes to the education category, lower secondary has the highest loan defaulter, followed by the secondary special. When it comes to the family status, single or not married clients has the highest loan defaulter, followed by the civil marriage category. When it comes to the housing type, with parents housing has the highest number of loan defaulters, followed by a rented apartment. When it comes to the occupation type, low skilled laborers has the highest number of loan defaulters, followed by the drivers. When it comes to the organization type, business entity type 3 has the largest number of loan defaulters, followed by the self-employed. When it comes to the number of children, the client having 9 number of children has the highest number of loan defaulters with 100%, whereas 5 children has the second highest. When it comes to the number of family members, the client is having 2 family members has the highest number of loan defaulters, followed by the 1 family member. The client one who is not having a car has the highest number of defaulters. The client not having their own property or home has the highest number of loan defaulters. When it comes to the client region rating, the rating 3 has the highest rate of loan defaulters, followed by the region rating client 2. When it comes to the bivariate analysis, the largest average credit amount is found in the range of 4,50,000 to 4,75,000 in the income category, followed by the 5 lakh and above. When it comes to the 46 to 50 age group, has the average credit amount of 6,66,000, whereas 51 to 55 age group has the second highest average credit amount. When it comes to the income category, businessman has the highest average credit amount, followed by the maternity leave. When it comes to the when it comes to the income category, 500k and above has the highest average product price, followed by the 450k to 475k, that is 4,50,000 to 4,75,000 income bracketing. When it comes to the consumer, when it comes to the contract type, consumer loan has the highest unused offer rate, whereas revolving loan has the highest acceptance rate. On the other hand, highest rejection rate is having XNA, and also with the cancellation rate. When it comes to the cash loan purpose, XAP has the highest approval rate, and the electronic equipment purchase has the highest unused offer rate, whereas when it comes to the XNA, it has the highest cancellation rate. When it comes to the products category, additional service has the highest approval rate, XNA has the highest refusal rates, and also the cancellation rates refer to the XNA. When it comes to the mobile items, has the highest unused offers. Moving to the next task, that is identify top correlation for different scenarios. Finding trustworthy predictors of loan default may be made easier by learning about the relationship between variables and the target variable. Divide the dataset using the Excel tools into categories such as clients having payment issues and all other situations. Then find the best connection for each subset of data. Use Excel tools like Corel to find correlation coefficients between variables and the target variables within each segment. Sort the association to identify the most significant loan default signs for each scenario. Creating a heat maps or correlation matrices to see the relationship between the variables in each section. Make use of the different coloring to highlight the elements that are the most related in each case. Coming to the Excel, we have done two separate sheets, that is for a target 0 and for a target 1. That is the client is not having any issues with the repayment, and the client having issues with the repayment, by using this sort formula, using this filter tool. So this is how we have got. So in order to know this formula, for example, just we need to use the formula. Okay. And then when it comes to the target 1, so we need to select from which column to, from which column we need to select, click on that and click on comma and then select the target variable and then click enter. So for number of children to amount income total has been generated here. Same like this we need to predict all the other variables separately for target 0 and target 1. Coming to the report, by doing this analysis I found out that the loan default is significantly correlated with the past due payments, low credit scores and a history of late payments. A history of late payment, high debt to income ratios and a high volume of credit inquiries all suggest a potential default risk. In different market segment, credit ratings, debt to income ratios and past payment habits are all reliable indicators of loan default. These are the top 10 correlations for target 0. That means the client have no issues with the repayment. These are the top 10 correlation. These are the top 10 correlation to the target 1, that is for loan defaulters who have repayment difficulties. Next, moving to the last and final part of the presentation, that is result. This research provided valuable insights into the examination of data in datasets that have information about loan application. I carefully looked into how to manage missing data, identify outliers, and analyze data imbalances using Excel features and capabilities. Through dataset analysis and detailed examination of the relationship between various attributes and loan default, I was able to gain a useful understanding of the elements impacting loan default. Decision making in the loan industry and risk assessment is depending on this knowledge is very important. Thank you for this opportunity to present this project.